Hello everyone, how are you? Today let's code again. We will solve Leetcode problem number 7, which is a reverse integer and it's of medium level. And the problem is we are given a signed 32-bit integer, and here 32-bit integer is very important to focus on. So that means the x value can be arranged between positive 2 to power 31 minus 1, which is this number, to negative 2 to power 31, which is this number. That means we cannot go beyond these numbers. When we have a result, the output cannot be bigger than this number or smaller than this number, because in negative smaller mean in absolute value it's like a bigger number. It needs more bit to store the value. So we're assuming our result is also 30-bit signed integer, cannot hold bigger size than these two numbers. So our range is between these two numbers. Okay, so simply how we can solve this problem? Let's assume we have x equal 1, 2, 3. If positive, we need to return 3 to 1, like 321. So simply we can first take the x, we do remainder division with 10 to get the first digit, which is 3. And this 3 later we will store in the result. We have result initialized to be 0, and we say result equal 10 multiplied by current result. I will tell you why. Okay, plus the digit which is here, plus 3, the digit, new digit. First result is 0, it will be 0 plus 3, so the beginning of the result it will be 3. Then we no longer need this one, so new x value will be x integer division by 10, and it should be 12. It should be 12. And this 12 return back to this one, and the next remainder division by 10, it will be 10. And here we come, the current result is 3. 3 multiplied by 10 is 30, plus 2, it will be 32. Okay, and here x, we will integer division by 10, it will be 1, and 1 come here, and 32 by 10 is 320 plus 1. Final result will be 321. If it's negative, the same idea, the same theory will apply here. Okay, we have a problem here, and this problem is in Python. These work perfectly with the positive number, but does not work well with the negative number. For example, if we have negative 101 remainder division by 10, in Python it will give us 9. It will not give us minus 1 for some reason. So we can use an alternative. We can use this math.fmod library, and we give it minus 101, and we want to divide it remainder division by 10, and it will give us minus 1. This is with Python, so it's not necessarily the same case with the other language like C or Java or JavaScript or whatever, but in Python it works like this. Also, the integer division, for example, here minus 106, integer division by 10, it will give us minus 11, but we should get minus 10. So we use integer normal division, and we take its integer, and it will give us the correct result. This is we need to focus about. Also, let me show you other edge cases, or how to be focused. We don't go outside our range. And for example, this is our range here. So when we reverse the number, when we reverse it, okay, we need to focus when we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. These 10 digits cannot, or let's say these 9 digits, if these 9 digits, like 214,7,4,8,3,6,5, and there's x here. If we are storing our result and we reach to this number, we need to check, is this bigger than this or not, or is it smaller than this or not, because this is negative. If it's bigger than this or smaller than this, there's no need to check the last digit, because whatever the last digit, the result will be outside the range. You see, even if we put 0 here, it will be bigger than this, or smaller if it's negative, smaller than this. So outside our range. So there's no need to continue. If this number, for example, exactly 4, we need to check the last digit. Is it bigger than 7, or is it smaller than 8? If so, if it's negative, smaller than 8, if so, then we are also outside the range. So, and I will show you how we do it in the code, but I want to show you how it works. Yes, so let's go to the code and start coding. Okay, so first we define the min, which equal minus 2147,4,8,3,6,4,8, and the max will equal to 214,7,4,8,3,6,4,7. Okay, we start the result equals 0, and while x, we iterate through every digit in x till the x reach value 0, and we will get out of the loop. So first we take the digit, which, as I told you, we use this library math.fmod for x division by 10, and the new x value will be integer of x division by 10. So if result bigger than max, then we are outside the range, and this is not good. Bigger than max, integer division by 10, or result equal max, integer division by 10, and digit is bigger than max mod 10. This is for positive number. Okay, then we return 0. So if the result, as I told you, max 10 takes all digit on the left except the last one. If it's bigger, then we have to quit. Or if the results equal to the left digits except the last digit, and the last digit is bigger than the last digit, also we have to quit. This is for positive. Now for negative. If result smaller than integer min division by 10, or result equal the integer of minimum division by 10, but we need to check the last digit, and last digit, is it smaller than integer math.fmod min 10, and how many? These 3, I think I need to close here. We return 0. Then simply we say result equal result multiply by 10 plus the new digit, then return result. That's simple. I think I missed one parenthesis. Yeah, I should put one more here. So let's run our code. Expected. Yeah, I should also put here, and then yeah, it looks reverse. Let's try this as a negative number, and error says result is not defined. Why? I maybe misspelled something. Where I said results, where it's result. So yeah, errors happen, and yeah, the reverse is good now. Let's now copy our code and test it in the Leetcode. Maybe some people ask me why you tested in the Leetcode, because like in Jupyter I maybe made 1 or 2 tests, but in the Leetcode it actually make so many tests that maybe I missed some edge cases or something, and Leetcode it will catch it, it will show it. So it's working very well. You can see the runtime is good, the memory is good, and everything is good. Thank you for watching. Please don't forget to put a comment, and good day.